Cambridge AS Computer Science, Chapter 4, Processor Fundamental, Part 2, Fetch Execute Cycle, or sometimes they call it Fetch Decode Execute Cycle. Okay, this cycle has been spoken about. We talked about a little bit. This cycle is best explained using this diagram. Let us go back to this diagram and let us recap on what we have studied. Okay? Okay. This is the most important diagram in this chapter or in this topic. Okay? Because it shows everything inside of the processor. Okay, so what do we have? We have 5 registers. You have to study this and remember this very, very well. We have 5 registers. You have to know them by name and you have to know their purpose. And these 5 registers are from the O level. Okay, however, here I will add 2 additional registers, not in the O level. Okay, I will talk about them more in details very soon. Okay, so here we have, this is the program counter. The program counter holds the address of the next instruction to be fetched. I will explain the fetch, decode, execute right now on this diagram because it strongly involves all of the 5 registers. Okay, so the program counter holds the address of the next instruction. Okay, the program counter, the contents of the program counter will be copied to the memory address register. Why? Because we want to send the address, the program counter holds an address. We want to send that address to the address bus, to the memory. We want to send the address in the program counter to the address bus to the memory. However, to send an address to the address bus, first it goes into the memory address register, MAR. So first it goes to the memory address register, MAR. So the contents of the program counter is copied to the memory address register. And this automatically implies that now it is on the address bus and it will very soon reach the memory. Okay? Okay. So this is the first thing to say in the fetch, decode, execute cycle. Actually, I'm just explaining the fetch stage. The fetch stage. What is fetch? Fetch means bringing an instruction from memory and putting it inside of the processor. I will tell you where inside of the processor that instruction will go. Okay, so the contents of the program counter, you can start saying the address of the next instruction is in the program counter. That address is copied to the memory address register and then goes through the address bus to the memory. Okay, now the memory operates. How? It has received an address. Okay, so the memory operates as follows. It goes into that address location. It goes into that address location and reads the data in that address location and sends that data along the data bus. Okay, so now the address is becoming a data. Okay, the corresponding data in that address. Okay, so the address now is coming along the data. I'm sorry, the data now is coming along the data bus. Okay, so the data on the data bus is sent now towards the processor. Okay, and it is received in the memory data register. So now you have some sort of similarity because memory address register is connected to the address bus, memory data register MDR is connected to the data bus. Okay, and let us assume that this data is an instruction. What is that instruction? An instruction in machine language or in machine code that must go to the processor to be executed. So the data or instruction, so the data or instruction from the memory data register goes to another register called CIR. That register, CIR, is called current instruction register. That register is very close to or inside of the control unit. Okay? So now the fetch cycle or the fetch stage is about to finish. Why? Because the instruction has arrived into the current instruction. The instruction has arrived into the current instruction register, CIR. The current instruction register, CIR. Okay? Okay? There is one little thing to say, and then I can say, okay, now the fetch stage is complete. At the end of the fetch stage state, I increment, or the processor increments the program counter by 1. So the program counter is incremented by 1. Why? Because in the next cycle, okay, the program counter will be pointing to the instruction or the address after, so that the program will run. Okay. Okay. Now the fetch cycle has completed. Okay. The fetch cycle is complete now. Okay. So the required instruction is inside of the current instruction register. The required instruction is inside of the current instruction register. Okay. Then comes another stage called decode. What is that decode? It starts interpreting that instruction. We will study this in details because we have to study this. We are here doing the fetch execute cycle, or fetch decode execute cycle. You have to know both names, and they both refer to the same thing. Sometimes they explicitly mention the decode stage, or just they say it fetch execute cycle. Because, okay, we will also have to look at this register transfer notation. I will tell about it in a minute. Okay, okay, because this is a machine code instruction. So this is an instruction. This is the format of an instruction that has just been fetched and put inside of the CIR, current instruction register. Then the control unit starts decoding that instruction, dividing that instruction into those 4 parts. So 4 bits for the operation, 2 bits for the address mode. We have to teach today address mode, and 4 bits for the register addressing, and 16 bits for the operand. You don't have to know explicitly what are these. However, you have to know that now the decode stage is about interpreting or parsing. We call it parsing. Okay, dividing the instruction into those parts. Okay, so the stage after the fetch cycle is the decode cycle. Okay, now the processor, after decoding the instruction, knows how to execute it. What is meant by execution? Perform the actions required. So after decoding comes execution. So the action required is performed. So the fetch stage, okay, and you know the steps in that fetch stage, and then the decode stage, splitting the instruction into its parts, and then the execute stage, and then another fetch cycle, another fetch decode execute cycle. Why? Because you go to the program counter and you find now it has been incremented by 1. You go to the program counter and you find it pointing to the address after the one that has been executed. And then what? Okay, let us do the cycle again. The program counter contains the address of the next instruction. The address in the program counter is copied to the memory address register. The memory address register goes to the address bus. The address bus goes to the memory. The memory operates by sending the appropriate data, okay, along the data bus, okay, and it goes into the memory data register. Okay, let us assume that this is an instruction. It goes into the current instruction register, and you increment the program counter by 1. This is another cycle of the fetch cycle. Then what? Then decode. Decode the instruction. Then what? Execute the instruction. Then what? Another fetch cycle. And this cycle goes on very fast. And the system clock is synchronizing all these stages. Okay? And this is what is meant by a program running. This is what is meant by a program running. A program running, the instructions are in the memory. There is one little exception or one little addition. Okay, I will tell it here. During the execution, there may be some data to come from memory. That data we call them operands. Okay, during the execute, the processor may need operands. Those data, those operands will come along the memory data register. However, they will go into the accumulator ACC. The accumulator ACC is a general purpose register, okay, that holds intermediate or final results of calculations because it is inside or connected to the arithmetic and logic unit, ALU. Okay, any arithmetic calculation, any logic operation will be done on the data in the accumulator, and write the data back to the memory. Okay, so this is what is meant by a program running. Okay, okay. We have registers. I'm recapping on the previous session. Okay, I assume that this part is the most difficult part to understand in the theory of the AS, because it is really technical, it is really engineering inside of the processor. Okay, so you have registers. The CIR and its purpose, it holds the current instruction. The MAR and MDR, one of them is connected to the address bus and the other is connected to the data bus. The PC, the program counter, okay? And where is the accumulator? The accumulator is a general purpose, the accumulator ACC, okay? Those have been taught in the O-level, okay? Now I need to talk about 2 additional registers. One of them is called the status register. The status register. Okay, I said that in the previous session. The status register have individual bits that are treated as flags. Each flag indicates a status, a situation or something. Like, for example, overflow. When there is an overflow, there is a flag or a bit in that status register that is raised into 1 when there is an overflow. Okay, when there is a carry, when there is a 0. Okay, so this is the status register, and the exam may ask you about explaining the purpose of the status register, the program counter, everything. Okay, yeah, everything is already explained except the IX or the index register. I will keep this for a moment. Remember, there is a register called the index register, IX, and this is used with addressing modes. There is, what is that addressing mode? I think I need to tell it right now. Okay, I will tell about various addressing modes. Okay, and that time when I tell about addressing mode, I will tell you, please remember, there is a register I did not explain about. I am keeping it until I explain addressing modes. Okay, store a value that is used for indexed addressing. Okay, let us keep this for addressing mode. Also, you should know about address bus, data bus, the control bus, and the clock, system clock. Okay, you should know about all these because we told those things in the previous session. Okay, this is a flow chart for the fetch, decode, execute cycle. Okay, I said everything in here. Just learn it. Okay, let me tell about that register transfer notation. I will re-explain. I will re-explain. Okay, the fetch cycle using register transfer notation. What registers do I have? The program counter, the MAR, the MDR, the CIR. Okay, so please remember that I said the contents of the program counter will be copied to the MAR, memory address register. It is written like this. And those brackets mean the content. So the content of the PC, the program counter, is copied to the MAR, memory address register. Okay, and increment program counter by 1. So the contents of program counter is incremented by 1. And then you have here 2 brackets. You have inner bracket and outer bracket, double brackets. Why? Because the content of the MAR, so here this means the double bracket in here means the content of the content. So the content of the MAR, the memory address register, goes to the memory, and the content of that address is the data coming from that memory. So it is the content of the content. So the double bracket means the content of the MAR goes to the memory, and then the content of that addressed cell or that address, okay, comes from the memory and is sent along the data bus to the MDR. And then the content of the MDR goes to the CIR. Okay, this is just the fetch cycle. This is just the fetch cycle written in register transfer notations. Sometimes they ask you to explain it from the using text or using register transfer notation. You will see these in the exam frequently. Otherwise, I wouldn't have spent much time on it. Okay, so sometimes they give you the code like this and you explain it. Some other times they give you the explanation and you write the code for it. So this is the register transfer notation. And even once they said, what is the purpose of that double quote? They even once said, what is the purpose of that double bracket in the bracket MAR? It said that the answer at that time, the content of the MAR is an address. It is the content of that address which is transferred to the MDR. This means the contents of the address pointed to by the MER is transferred to the MDR. I hope now everything I'm saying is clear and familiar for you. MER, MDR, these are very important registers, or the only registers you need to study about, except the IX that you haven't studied about till yet. Okay, so this is the fetch, decode, execute cycle. This diagram, this flow chart, that doesn't tell much, except one little thing I need to point you to and then start explanation about. Okay, that interrupt thing. At the end of each cycle, it checks if there is an interrupt. That interrupt thing is very popular since the O level. That interrupt thing is very popular since the O level. Okay? Okay? Please go and study these very carefully. Okay? Look at this. Look at this. This is an exam question. And I copied the mark scheme into my notes just because to save your time without referring you to the past paper. We will go soon to the past paper and then you will see that example. The question said, the memory address register MAR stores an address. The contents of this stored address are copied to the memory data register. Okay, so you have to write here MAR and bracket and another bracket because it is the content of that content. Because the content of the MAR is an address that goes into memory that brings another content, which is the data corresponding to that address, and it will be assigned to the MDR. So instructions here are not necessarily in the correct order. Okay, so A, they give you an explanation, and this is your answer. Okay, another question. The content of the program counter PC are copied to the memory address register MAR. Okay, the program of the PC is copied to MAR. Okay, the content of the memory data registers are copied to the current instruction. Okay, the content of MDR is copied to the CIR. The content of the program counter is incremented or arc incremented. Okay, so PC becomes PC plus 1. And then at the end of that question, they ask you to give the correct order of these instructions in the fetch, decode, execute cycle, or in the fetch cycle to be precise. So what is the order? B comes first. B comes first. And then A. And then C. And D, that is PC becomes PC plus 1, is at any point after B. Okay? The order of steps in the fetch cycle would be first B. That is MAR, program counter is copied to the MAR. And then A, the content of MAR is copied to the MDR. And then C, the content of the CIR, MDR is copied to the CIR. And D, put anywhere after B. Okay? You may increment it any time after copying the program counter to the MAR. Anytime. The exam will give you a word you amount. Okay, then we need to speak about interrupts. Interrupts are very, very, very critical. They are very, very important. They are very, very popular. You study it from the O level till the A2. What is an interrupt? A signal from a component to the processor seeking its attention. An interrupt could result from software interrupt or hardware interrupt. So a program may raise an interrupt. A hardware device may raise an interrupt. Why? In the first place, you can say interrupts occur when an error occurs. But this is not exclusive. This is not inclusive. Okay? So interrupts, first, they occur when an error occurs. When an error occurs. So, for example, software error, divide by 0. This is impossible. So the software sends an interrupt to the processor and stops this from happening. Okay? So you are printing and the printer is out of paper jam, or disconnected. The printer sends an interrupt to the processor and the printing process is halted. Okay? So these are examples of interrupts. These are examples of interrupts that are sent as a result of error. However, interrupts occur quite often. When you press on a keyboard, when you press on a key on a keyboard, an interrupt is generated. Why? Because the keyboard is very slow. And the fetch, decode, execute is going on so fast. The clock is 2 giga. So giga is 9 zeros. So 2 billion instructions per second. And when you click on the keyboard, So the processor is leaving the keyboard, and when a user clicks on a button, the keyboard sends an interrupt to the processor seeking its attention. Okay, when you move the mouse sends an interrupt to the processor seeking the attention. And what is that seeking attention? The processor halts or stops the program it is running, and then it runs what is called interrupt service routine, ISR. You have to know all this. You should have already studied that in the O level. Okay, but I'm teaching for those who haven't taken the O level. Okay, so when you move the mouse, an interrupt occurs, the processor halts whatever it is doing, and then runs what is called the interrupt service routine. Okay, interrupt service routine updates the position of the arrow on the screen, and then the processor resumes the program it was running. It resumes the program. And this happens without noticing. This happens because I'm telling you that it is running at the speed of 2 gigahertz. And this is 2 billion things a second. Okay, so you never notice that a program has been suspended unless the computer is very, very slow and the processor is very, very loaded. Okay. Okay, so the interrupt, causes of software interrupt: division by 0. This is called runtime error. Attempt to access an invalid memory address. Array index out of bounds. Okay, remember arrays in programming. So, for example, you declare an array from 1 to 100, and you want to access location 105. There is no location 105. Okay, so an interrupt occurs. Okay, stack overflow. We haven't studied stacks yet. Okay, okay, so these are examples of, actually, you should notice things in that color are just these are mark schemes. These are mark schemes. So expect that there was a question that said, what are the causes of software interrupts? I said interrupts may be caused by software or may be caused by hardware. Okay, I hope you know everything about interrupts. Okay, and there is what is called interrupt service routine. Okay, so interrupt handling. There are many different reasons for an interrupt to generate. Some example: fatal error, hardware fault, input output. Okay, so for every interrupt there should be an interrupt service routine. Okay, let us go a little bit further because I need to explain a lot. Okay, I should have paused here and refer you to the past paper, but I have to explain a lot. Then we come to machine code instructions, because I am preparing you to study assembly language, low-level assembly language. Okay, so assembly language is just another side of machine code instructions. However, instead, machine code instructions are purely ones and zeros. So instead of purely using ones and zeros, okay, we use mnemonics. You should know about assembly language from the O-level stage. Okay, let us go into it and explain the new topics, because here I need to explain addressing modes. Okay, here I need to explain the addressing modes. Okay, and then I give you a brief about assembly language instructions and their groups and their meanings. Hopefully next we study programming in assembly language. Okay, because this is in your paper 1 question. Okay, so machine code instructions are just ones and zeros. These are the instructions that are fetched from the memory and put into the CIR, current instruction register, to be decoded. Okay, the only language the CPU recognizes is the machine code. When a program is run, an instruction is fetched. You should learn that word fetch. Okay? Okay. It has to be in the format of a binary. Okay? A machine code instruction is a binary code with defined number of bits. And that classification of what is the meaning of every group of bits, this is done in the decode stage of the fetch, decode, execute cycle. Okay, we already told about this. Okay, you don't have to study this. You don't have to study this very well, very hard. Because just know that this is a machine code instruction that will be fetched and put in the CIR and then interpreted. Interpretation means defining the 4-bit operation bit and what do they do, the addressing mode. We have to study now various or maybe 4 or 5 addressing modes. Okay, let us go to assembly language. Assembly language is just machine language, however, using mnemonics instead of ones and zeros. What is that mnemonics? You have to study these. You have to study these. LDM, LDR. Fortunately, you don't need to memorize them, but you have to be familiar with them. Why? Because this is what is called the instruction set. This is the instruction set that the processor understands. Fortunately, this instruction set has to be explicitly written for you in your exam paper, in your question paper, because they change from processor to processor. You are not supposed to memorize them. However, understand them because you need to be able to use them. Okay? So these are mnemonics. So let us go directly into assembly language. I'm pushing you ahead. I am pushing you ahead. So assembly language instructions, we have data movement groups that move data from register to register, move data from address to register, probably the accumulator. And that data movement group strongly depends on memory addressing modes. I will go right now, I will go back in a minute and tell you about addressing modes. We have to know them. It is time to know addressing modes. Okay? But we have data movement group. We have arithmetic operation group, add, increment, or decrement. We have comparison group and jump group, JMP, CMP, whatever. We have input and output group. We have many examples of instruction set. Okay. Let us now, these are examples of addressing modes. Okay, so this is what is meant by assembly language. I just showed you what are the examples of assembly language. A programmer may wish to write a program where the actions taken by the processor are directly controlled. When you want to control the actions, you write in low-level assembly language. Otherwise, you write in high-level assembly language, high-level language with a pseudocode or so, without knowing the details inside of the process. Okay? The essence of an assembly language, it uses mnemonics. I showed you mnemonics, MAR, MDR. These are called mnemonics. Those mnemonics stand for opcodes. Those mnemonics stand for opcodes. This is so fortunate because we cannot deal with ones and zeros. Okay? A character representation for the operand. We will see this. Okay? Okay, let us study addressing modes. Let us study addressing modes in preparation for studying low-level assembly language. Okay, so when an instruction requires a value to be loaded into a register, there are different ways of identifying the value. You want to put a value in a register. probably that register will be the accumulator. I hope you understand me. If you have any question, just raise it. Okay? So, we want to put a value into the accumulator. If we use the immediate addressing mode, okay? Okay, so if we use the immediate addressing mode, this is the opcode and this is the value. Look at this diagram. This is immediate addressing. So the value here will go into the register, into the accumulator. This is called immediate addressing. I will give you an example. LDD, which means load, for example, #5. It always comes preceded with a hash. LDD #5, for example. I'm not very precise with that example, but just for example, LDD #5. And if this means immediate addressing, which means the 5 will be loaded into the accumulator. Okay? So for example, LDD #5, anything preceded with that hash is just immediate. That 5 goes into the accumulator. Okay, simple. This is called immediate addressing. Next, we have direct addressing. What is that direct addressing? I give you, for example, LDD and then without a hash. LDD without a hash and then 50. That 50 is an address. Okay, so here the #5 is the value. #5 is the value. #5 is with immediate addressing. Okay, however, for example, 50 without hash is an address, and this is direct addressing because you take the address and bring the value from memory and put it into the accumulator. So here you don't refer to the memory. Immediate, you don't refer to the memory. You just take the value #5 and put it directly into the accumulator. You don't refer to the memory. Okay, this is immediate addressing. With direct addressing, you are provided with an address. You go to memory, bring the value corresponding to that address and put it in the memory. This is direct addressing. Okay, let us take it one more step. There is indirect addressing. There is indirect addressing. You are provided with an address that goes to the memory, and you find in that location another address that goes to another location in the memory. You copy the content of that second location in the memory and put it in the accumulator. Well, this is indirect. So direct, you go directly and get that value from that address and put it into the accumulator. Indirect, you go to an address, you find another address. You go to that second address, you get that value and put it into the accumulator. Why so? Why? We need it. There are many examples later on. Actually, all these come in the exam. All these. Okay, you have to play them and show a bit of understanding about this, and then you get all the marks. Okay, but there are real practical situations where these are necessary. Okay, so now I told you about immediate, the value provided goes into memory. Direct addressing, the value provided is an address, and the value comes from that address into memory. And then indirect, that value is an address for a second address, and the value in that second address goes into memory. Okay? What is that? Next, indexing. Remember the register I refuse to teach you? I refuse to tell a lot about, because at that time, it wouldn't have any sense. Okay? There is a register called the index register. Okay? For some reason, maybe later on, you will be convinced why you need that. For some reason, you will be provided with an address. You add, this is indexed. You are provided here with an address. You add the value in the index register to that address, and this is the memory location to get the data from. This is just indexed addressing. So if the IX has 10 and you are provided with 50 plus 10, you go to 60 and get the data and put it in the accumulator. It is so simple. Just know that there is an index register that will have a value, and that value will be added to the address given. Go to that new calculated address and put it in the accumulator. This is what is meant by indexed addressing. This is what is meant by indexed addressing. Again, I know it is difficult to understand, but immediate, the value is immediately put into the accumulator. Direct, the value provided is an address for the data. Indirect, the value provided is an address for another address. Indexed, the value provided will be added to the value in the IX, and then this is the address. What is last? There is something called relative. It is not very difficult than indexed, and it is not very popular. So relative is related to the address of the memory of the first instruction of the program, or related to where you are there. This is not so important right now. They don't show it much in questions because it is confusing. Okay, so relative, the address provided is relative to the location of that instruction. You add to it the contents of the program counter. Don't spend a lot of effort on this. We will get so many examples and we will understand everyone. Okay, let us look at this. Let us look at this exam question. Okay. Direct addressing. Direct addressing. The operand is the address of the value to be used. The operand is the address of the value to be used. So with direct addressing, you are provided with an operand. That operand is the address of the value you need to find. This is direct addressing. Immediate, the operand is the value itself. You don't need to refer to the memory. Immediate, the operand is the value itself that will go into memory. In indexed, remember, the operand plus the contents of the index register. So indexed addressing, the operand plus contents of the index register is the address of the value to be used. Indirect, as you can see, the operand is the address of the address. Indirect, you go to an address and refers you to a second address. This is called indirect. There should be some practical reasons why you need this, but we don't need to tell it right now. Okay, relative, the content is the offset from the current address where the value to be used is stored. It's an offset from where the code is running, from the program counter. Okay, I think you will be able to solve this question. Okay, another question. As you can see, topics I'm telling you are in the past paper. Just at the end of my session, go to your past paper and you'll find these. You will find these questions. So they are giving you a description, and you have to write here. Similar to giving a description and a name, and you need to connect. So from the form the address by adding the given number to a base address. Load the content of the calculated address to the accumulator ACC. This is relative. You add to it a base address. Load the content of the address held at the given address to ACC. This is very simple. This is No, this is not very simple. Load the content of the address that held at the given address. So it's an address to another address. This is indirect. Load the content of the given address to the ACC. This is direct. Form the address from the given address plus the contents of the index register IX. Load the contents of the calculated address to the ACC. This is indexed. Load the given value directly to the ACC. This is immediate. Okay, so these are the addressing modes. Let us go through assembly language instructions and put them in groups and study them as much as possible, understand them very well. Okay, this will help you understand addressing modes, and you will find few, not very big, because there used to be complex questions about this, but not anymore. Simple questions, programming in assembly language. You don't need to program. I think you only need to create a trace table, trace a program. Okay, we will see. However, let us understand meanings and groups. Let us understand groups of assembly language instructions, and hopefully they will be written in your question paper. Okay, you will see questions. I have all the questions ready in my notes for direct practice. The processor instruction set. We are now dealing with the instruction set. Can be put in several groups. There are groups: data movement group, arithmetic operations group, comparison group and jump group, input and output group, and that's it. Okay, let us study those groups and give examples about instructions that belong to every group. But you have to study this. You have to study this and memorize it. So one of these groups is data movement group. Another is input and output group. Another is arithmetic operation group. Another jump instruction group. Another compare instruction group. Coming with modes of addressing already studied. Coming with modes of addressing already studied. So once there was a question and it said, mention groups of instructions in the assembly language. The question asked about groups of instructions in the assembly language. Your answer was data movement group, arithmetic operation group, jump instruction group, compare instruction group, input and output of data group. Okay, just know them very well. You have to study them. Okay, let us look up a data movement group so you have better understanding. For example, these type of instructions can involve load data into a register or storing data into a memory. So move data from a memory to a register, probably the accumulator. Probably the most frequently used register with data is the accumulator, ACC, that is inside of the arithmetic and logic unit. Refer to the registers told about in the beginning of this session. LDM-N. Oh, so this is immediate addressing. We will tell now again about addressing modes. So LDM-N, that N preceded by a hash is the immediate value to put in the accumulator. Immediate addressing, loading N to the ACC. Okay, so very clear. And this should be written in the exam. However, your understanding about what is meant by immediate is very necessary. LDR, another instruction. Hash N, immediate addressing, loaded N into the IX. Okay, okay. So the hash N, the value immediately goes into the IX. LDD and address without hash. LDD with an address without hash. This is direct addressing loading to the accumulator. LDI without hash. Indirect addressing. So direct addressing, indirect addressing, indexed addressing, all addressing modes except the relative addressing is not so popular. All the addressing modes are in here. And then store is doing the opposite. All of these are getting data inside of the accumulator. This is store comes from store, storing the data into the accumulator to somewhere in memory. And the only version you have here is storing the contents of the ACC. I think this is direct address. Okay, so these are data movement group instructions. Okay. Let us move on because I need to finish very soon. Arithmetic operation. Add with an address. Add with an address. Add the address content to the content of the ACC. So this is direct addressing. You are provided with an address. You bring the value from the memory and adds it to whatever in the ACC, in the accumulator. INC register increment, add 1. INC comes from increment. And then comes the name of the address, increment the ACC or increment the IX. This DEC means decrement. Okay. What else? Comparison group and jump group. Jump into an address. We will clarify this more, but just for today, study all these. And next session, we will do examples of these where things become clear. Okay? Jump means jump, go to a location and start executing from there. Jump. Yeah. So this changes the program counter. The program counter is incremented by 1. But when you jump to location 100, you start executing from location 100. CMP means compare. Compare the immediate value. This is immediate addressing. Compare the immediate value. Compare the immediate value with whatever in the accumulator. Or CMP, compare the address with the accumulator. Jump if that last comparison was equal. Jump equal, jump if that last comparison was equal. Jump not equal, jump if that last comparison was not equal. So this is unconditional jump, this is comparison, and then jump if equal and jump if not equal. You know what do you need this? Because this is how they do the if then else programming. This is how they do the if then else programming in assembly language. Okay? Okay. Okay, one little word and then we recap and revise and calm things down because I know I'm putting so much information on you. Please try to accept and study. And next, we will do questions about it. The last thing is input and output group. You only have 2 instructions. One is called the in and one is called the out. In takes a value from the keyboard and loads it into the accumulator. Out takes a value from the accumulator and displays it on the screen. However, when there is a value in the accumulator and out displays it on the screen, it treats that value as ASCII code. So for example, if the value is 67 and out 67 and B 67 is the ASCII code of B, so B is displayed on the screen. Okay, so in and out deal with ASCII representation. If you need to do input and output, they will provide you with a small part of the ASCII table. So for example, on the keyboard, if there is an instruction called in, and that instruction accepts, for example, a letter from the keyboard, okay, and then that letter you press on A, the ASCII code of A goes into the accumulator. Okay, please study these because I don't have time to read everything written here. I hope I have explained them well. Please study these because next we will have to do little programs like this. And I will be teaching you the most recent examples because they are much, much easier than older examples. Okay, let us look at 2 examples from the past paper and then I will end. You have to know them. You have to know them. For example, you are given with STO 120. What does this mean? You have to take that this is data movement. This instruction belongs to data movement group. So simple. So STO belongs to data movement. JPE belongs to jump instructions. You have to know the group. Add 3. This belongs to arithmetic group. Load 20. LDD 20. I don't mind whether this is direct or indirect. I don't know. I don't care. I just need to say that this is data movement group. This belongs to the data movement group. INC increment. So it is arithmetic group. INC ACC increment, the accumulator, means add 1 to the contents of the accumulator. However, I just need to mention that this belongs to the arithmetic group. Out, this belongs to the input output group. Another example. Input, so the question was input and output of data, nothing. None of these input or output data. So that was the answer. Data movement, tick on STO because it moves the data from the accumulator to the memory. Arithmetic operation, tick on increment. It increments the ACC. Unconditional and conditional jump. This is jump if not equal. This is conditional jump. Tick here. Compare instruction, there is no compare. CMP, there is no compare. Okay? And in the exam, in a real exam, otherwise asking you about groups. Otherwise, in a real exam, they will be providing you with a table like this. LDM #n immediate addressing. Load the number n to the ACC. LDD address direct addressing. Load the contents. All these will be in the exam. However, it is up to you to understand what is meant by immediate addressing, direct addressing, indirect addressing, indexed addressing, relative addressing. Fortunately, it is not here. Okay, you have to practice with these. These are compare. Okay, jump if equal, jump if not equal, in and out, and they deal with ASCII, as I told you. Okay, and returns control to the operating system. Okay, we can assume there is only one general purpose register available, the accumulator. This is the most popular. ACC denotes accumulator. IX denotes the index register. Address can be absolute or symbolic. Hash denote denary. So hash 1, 2, 3, which is immediate, and this value is in denary. B denotes binary and denotes hexadecimal. This is copied from the textbook. Next, I will show you examples copied from the exams. These are examples copied from the exam. I will do this next. I have to stop here. I hope everything is clear. Please refer to the classified and practice these topics. Thank you so much for your attention.